Why does fire exist? It sounds like a simple question. You've seen fire your entire life, campfires, candles, kitchen stoves. You strike a match, something burns, flames appear. End of story, right? Wrong. Most people never stop to ask what fire actually is. It's hot. It's bright. It destroys things. That seems like enough. But the moment you really ask what's happening, what's physically going on when something burns, you uncover something extraordinary. Fire isn't just a thing that happens. Fire is a window into how atoms behave, how energy moves, how the sun powers life, and even why trees exist at all. Let me show you. Take a piece of wood, dead, motionless. It can sit there for years. Now add air, oxygen floating all around it. The wood is there, the oxygen is there. Nothing happens. Why? Because chemistry is patient. Inside that wood is carbon. In the air is oxygen. Carbon and oxygen want to be together. When they bond, they release a huge amount of energy. That bonded state is more stable, it's lower energy, but there's a catch. To bond, they first have to get very close. And getting close requires energy. There's a barrier in the way. Think of it like a ball rolling toward a deep hole. The hole represents the stable, low energy state. But before the ball can fall in, it has to climb a hill. If it doesn't have enough speed, it rolls back. It never reaches the hole. That's what's happening with wood and oxygen. Oxygen atoms are constantly slamming into carbon atoms, millions of collisions every second, but they don't react. They hit, bounce off, and separate again. Not enough energy. The barrier holds. That's why a piece of wood can sit in open air for centuries and never catch fire until something changes. Heat. When you heat the wood, even slightly, a few atoms start moving faster. Suddenly, some of them have enough energy to climb over that barrier. They get close enough. They snap together. And when they do, energy explodes outward. That released energy makes nearby atoms move faster. Those atoms now have enough energy to react too. They snap together, release more energy, and speed up even more atoms. 1. Reaction becomes 2. 2 become 4. 4 become 8. In a fraction of a second, billions of atoms are reacting simultaneously. That runaway chain reaction, that is fire. Fire doesn't slowly fade into existence. It erupts because it's exponential, a self-feeding cascade. Once it starts, it sustains itself. This violent snapping releases energy as intense atomic motion, and that motion is what we call heat. Heat isn't a substance. It isn't a fluid. Heat is atoms jiggling. The faster they move, the hotter something feels. That's why a cup of coffee placed above a fire gets hot. The wild atomic motion from the burning wood transfers to the atoms in the cup. Fire is energy in motion. And here's the key insight. Fire is not a thing. Fire is a process. A feedback loop where heat creates reactions. Reactions create more heat, and the cycle feeds itself. That's why fire spreads. That's why it's so hard to stop. And the only way to kill it is to break the loop. Cool it down, remove the fuel, cut off the oxygen. Take away one side of the triangle, and the process collapses. But once you understand this, a deeper question appears. Where did all this energy come from in the first place? That wood didn't appear out of nowhere. It came from a tree. And the substance of that tree, its mass, is carbon. So where did that come from? From the air. This is one of the most beautiful misunderstandings in nature. Everyone thinks trees come from the ground. You plant a seed in soil, and a tree grows, so obviously the tree must come from the soil. But that's wrong. Almost all of a tree comes from the air. Carbon dioxide enters the leaves. Sunlight tears the oxygen away from the carbon. The oxygen is released back into the atmosphere, and the carbon combined with water becomes the substance of the tree. The soil contributes almost nothing except trace minerals. That tiny bit becomes ash when the wood burns. Here's proof. Take a pot of soil, weigh it, plant a seed, water it for years, let the tree grow large, and hey, then remove the tree and weigh the soil again. The soil weighs almost the same, but the tree weighs hundreds of pounds more. Where did that mass come from? Not the ground, not the soil. It came from the air. This experiment was done in the 1600s by Jan Baptista van Helmont. He discovered the tree didn't come from the soil. He thought it came from water. He was close. But the real answer is carbon dioxide from the air. And now the final connection. Fire joins carbon and oxygen, releasing energy. Trees use sunlight to separate carbon and oxygen, storing energy. Photosynthesis is fire in reverse. The sun does the work. Trees store the energy. Fire releases it back. Every flame you've ever seen is sunlight released years later. Fire takes carbon and oxygen and snaps them together. Trees do the opposite. A tree grabs carbon dioxide from the air and rips it apart. It uses sunlight to do real physical work, separating carbon from oxygen, storing the energy, and building structure. That structure is potential energy, i.e., the carbon and oxygen want to be together. They're happier that way, but the tree forces them apart and holds them there. And holding them apart stores energy. Now put that structure, the wood, into a fireplace. Surround it with oxygen, most of which was made by trees just like it. Once you add a little heat to get things started, everything rushes back together. Carbon collapses into oxygen, bonds reform, and an enormous amount of activity erupts. Light pours out, heat pours out. What you're seeing is everything being undone. When wood burns, you're going from carbon and oxygen back to carbon dioxide. And the light and heat released, that's the same light, deheat, that went into the tree in the first place. Fire is stored, sunlight escaping. Think about that. A tree spends years collecting sunlight photon by photon, using the energy to pull carbon out of the air and build itself. It locks that energy into chemical bonds. Then you cut the tree down, let the wood dry, stack it in your fireplace, strike a match. And years of sunlight come rushing back out in minutes. The flickering flame you're watching is sunlight that fell on leaves 5 years ago, 10 years ago, maybe 50 years ago. Stored as structure, released all at once. Every photon in a fire is, in a sense, recycled. Sunlight. So why doesn't wood just burst into flames on its own? If carbon and oxygen want to be together so badly, why do you need a match? Because of the hill. At room temperature, atoms aren't jiggling fast enough to climb over the activation barrier. They collide constantly, but they don't react. The system is stuck in what physicists call a metastable state. It's like a boulder balanced on top of a hill. It wants to roll down. That's the lower energy state, but it's sitting in a shallow dip, stable, as long as nothing pushes it. The match is the push. A small amount of heat nudges a few atoms over the barrier. Those reactions release energy, which heats nearby atoms, which triggers more reactions. And suddenly, the whole system runs away. That's why things don't just spontaneously combust. The universe is full of metastable systems, wood and ox. Hydrogen, gasoline, and air, food and oxygen in your body. They all want to release energy. They just need a trigger. Here's something even more mind-bending. Where did all the oxygen and the air come from? Plants. For billions of years, photosynthetic organisms have been ripping carbon dioxide apart, keeping the carbon and dumping the oxygen into the atmosphere as waste. Early Earth had almost no free oxygen. Oxygen was toxic to many early life forms. But eventually, some organisms evolved a trick. They learned how to use oxygen to burn carbon-based molecules and extract energy. That's you. The oxygen you breathe exists because plants threw it away. And that oxygen is what makes fire and life possible. So here's the full cycle. The sun shines. Plants use sunlight to split carbon dioxide, storing carbon and releasing oxygen. Animals eat plants or eat animals that ate plants. And inside your cells, you slowly burn that carbon with oxygen to release energy. That process is called respiration. It's fire, just slower, more controlled. Carbon plus oxygen becomes carbon dioxide, releasing energy. Same chemistry, same reaction, different speed. Your cells release energy carefully, capturing it in molecules like ATP. Fire releases it all at once as heat and light. You are, quite literally, a slow fire. When wood burns, chemical energy turns into heat and light. That energy was stored in molecular bonds created using sunlight. When those bonds break and new ones form, energy is released. Heat is atoms moving faster, light is electrons jumping to higher energy levels and falling back down, emitting photons. That's why flames glow. Different atoms glow in different colors. Sodium burns yellow, copper burns green, strontium burns red. Fireworks work because electrons don't all jump the same way. The smoke you see, tiny particles of carbon and other material that didn't fully react, rising because they're hot and less dense than air. The ash, that's the minerals, the tiny fraction of the tree that actually came from the ground. Everything else becomes invisible gas, carbon dioxide and water vapor, drifting back into the atmosphere. Nothing disappeared. It just changed form. And now, the final question: if fire is stored sunlight, if life is slow combustion, then how is the sun itself so hot? That's another story. And it's where things get truly strange.